Trigonometry has been used throughout history to solve crimes, fly airplanes, and construct some of the world's greatest monuments. Trigonometry is Greek for measuring triangles, and today that's exactly what we're going to do. Hey everyone, it's Andrew with Abarso ASAP, and before we begin this video, I recommend that you guys grab a calculator, and if you haven't already, you should watch Farhan's video from last week. Alright, once you guys have done that, we can get started. So, today we're going to be talking about the law of sines and cosines, but before we can get into that, first let's review some topics. So, first, all triangles have to have angles that sum up to 180 degrees. That is a must, and you guys should keep this in mind throughout the video. Next, the Pythagorean theorem. So all this says is a squared plus b squared is equal to c squared. And hopefully you guys remember this from geometry, just like this next thing that we're going to review, SOHCAHTOA. So, what SOHCAHTOA is saying is that if we have an opposite side to some angle theta, an adjacent side to that angle, and the hypotenuse of a right triangle, then these are the relationships that happen. So, sine of theta is equal to the opposite side over the hypotenuse of the triangle. Cosine of theta is equal to the adjacent side divided by the hypotenuse of the right triangle, and then tangent is equal to the opposite side divided by the adjacent side. So the lengths of the opposite side and the lengths of the adjacent side. So now we're going to discuss the law of sines. And the law of sines shows us the relationship between angles and the sides of a triangle. So unlike for SOHCAHTOA and the Pythagorean theorem, the law of sines can be used for any triangle. It doesn't have to be a right triangle. And so here in this diagram, you can see that we have the lowercase letters representing the side lengths and the uppercase letters representing the angles. So lowercase a is the side opposite to angle A, and then the same for B and C. And you can see this relationship here where the side length A over the sine of angle A is equal to the side length B over sine of angle B, which is in turn equal to the side length of C over sine of angle C. And so all of these are interconnected, and this is the relationship that they share with one another. So now that we've gone over this relationship, I want you guys to try to complete this triangle. So take a minute and pause the video to solve this now. Alright, so hopefully you guys have done so. Now let's take a look. So I have the relationship up on the left side of the screen, and you can see that here the side length 8 corresponds to the angle 30 degrees, and 12 corresponds to this angle x. So we're going to set up the relationship 12 over sine of x is equal to 8 over sine of 30. And if you guys remember from the previous video that Farhan did, sine of 30 is equal to 1/2. So we can actually rewrite this as 12 over sine of x is equal to 16. And then we can rewrite it further. Sine of x is equal to 12 over 16, which is equal to 3 over 4. So then we just take the inverse sine of 3 over 4. And that will give us x is roughly equal to 48.6 degrees. So now we have that, and we're just going to use the first property that we talked about. A triangle must add up to 180 degrees. So knowing that, we're just going to add 30 and 48 to get 78.6, and then subtract that from 180 to give us 101.4 degrees. So now we found this angle, but we haven't completed the triangle quite yet. We're still missing this side. So we're just going to apply the law of sines again. And so I used 8 over sine of 30 this time. You guys could use 12 over sine of 48.6. It'll give you the same number. And that number is going to be 15.7. Okay, so now take a look at these three triangles and think about which of these triangles could you not apply the law of sines to? So take a minute, pause the video if you need, and mull this over. Alright, so hopefully you guys have done that. Now let's discuss. So the triangle that you cannot apply the law of sines to is going to be the first one. And that's because we have this angle, but we don't have the opposite side length. And we have these two sides, but we don't have the opposite angles. So that makes it impossible for us to actually use the law of sines in this case. But we could solve that using the law of cosines. You see, the law of cosines tells us how to find an opposite side length to an angle when we know the two adjacent side lengths. So it's very similar to the Pythagorean theorem with just a little addition. So here we have c squared is equal to a squared plus b squared minus 2 times the side length of a times the side length of b times cosine of c. So knowing that, try finding the missing side length x. So take a minute, pause the video if you need. Okay, so hopefully you've done this. Now let's go over it. So we're just going to plug in these numbers to the law of cosines. So here we have x being the opposite side to this angle 60 degrees. So that'll give us x squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 60. And we can expand that out, and all the right side is going to give us, it's going to give us 124. So we'll get x squared is equal to 124. Then we just take the square root and we get x is equal roughly to 11.1. And so that's how we solve this problem. Okay, now that we've gone over the law of sines and the law of cosines, I want you guys to try completing this triangle by yourselves. So take as much time as you need, pause the video, solve this now. Alright, so hopefully you guys have done that. Now let's take a look. So we can see here that we know all of the side lengths of this triangle, but we don't actually know any of the angles. So we're going to need to use either the law of sines or the law of cosines to solve that. So if you said use the law of cosines, well, that's what I did as well. So we're going to set an equality. So c squared is equal to a squared plus b squared minus 2ab times cosine of c. So we just need to choose any one of these angles to work with. So I chose cosine of a. You could have chosen any of the angles you wanted to. So here we have 4 squared, and remember, we have to choose the side length opposite to the angle that we're going to use. So if you choose a, it has to be 4. If you chose to work with angle c, you should have chosen 12 to be this c squared. And if you chose 9, or excuse me, if you chose angle b, you should have chosen the side length 9 to be put in this spot. But anyway, I chose 4, so we have 4 squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of a. So I did all this work, you guys can see it right here, and basically we want to isolate a. So we have cosine of a is equal to 209 divided by 216. And one way you can tell if you're on the right track, or if you've fallen off the track, I should say, is if your cosine ends up being greater than 1, you know that something has gone wrong, because cosine is always going to be between -1 and 1. So always keep that in mind. Okay, so we have cosine of a is equal to 209 divided by 216. So we're just going to take the inverse cosine of that number. And that'll give us angle A being roughly equal to 14.6 degrees. So now that we have this, we can actually start using the law of sines to solve further. So we can set an equality here as well. So we have 4 over sine of 14.6, and we can set that equal to 9 over sine of b. And so we can solve further, and we'll get sine of b is equal to 0.567. And we'll take the inverse sine of that, and we'll get b is roughly equal to 34.6 degrees. And now we can complete this by just using the first property we talked about. All the angles in a triangle have to be equal to 180 degrees. So we just say 180 is equal to 14.6 plus 34.6 plus c. And so we can subtract 14.6 and 34.6 from 180, and that'll give us c is equal to 130.8 degrees. That concludes today's video. But before I let you guys go, here's some practice questions to really test your understanding of the material that we covered. So for the first one, I want you guys to try proving the law of sines and the law of cosines using only the Pythagorean theorem and SOHCAHTOA. It's going to be a bit challenging, but I know you can do it. And then for the second one, in the previous example, why should we be cautious using the law of sines to find angle C? So if you need, rewind the video to take a look at that triangle, but as you do so, really keep in mind, what is it about that angle that might be a bit different? Alright guys, if you like this video, if you feel like you got something from it, please give it a like and share it with your friends. If you haven't done so already, be sure to subscribe to Barso ASAP to keep up with your competencies. And I'll be sure to include some links in the description below so that you can continue learning about the law of sines and the law of cosines. Once again, this has been Andrew with the Barso ASAP, and I'll see you guys next time.